So last time, I hope you watched the video. Last time it was exponential functions and some applications of exponential functions. Going to go over something called implicit differentiation, and once we do this, I'll switch over to logarithms, and I hope you guys watched the video on logarithms that I asked you to watch maybe a week ago. If you didn't watch it, you're going to be completely lost. So suppose we have an equation of that sort and we want to find the derivative. Finding the derivative of x squared is easy. Yes? What is the derivative of x squared? 2x. But we all know that y depends on x. Y is usually a function of x. And naturally, y depends on x too. So I can't treat y squared as a constant. If y did not depend on x, then y squared is a constant. Derivative of y squared would be 0. But y is not a constant. So its derivative cannot be 0. But we know what the derivative of y with respect to x is. It is simply dy over dx. So what we should do in a case like this is to treat y squared as x squared. In that case, what is the derivative of x squared? Still 2x. Since we have y squared, we are going to write it as 2y. But we have to multiply it by dy over dx. The reason being y depends on x and it is not a constant. The derivative of the constant 4 is just 0. So we will end up having 0 on the other side. We have a 2 there, we have a 2 there. Divide by 2 on both sides, which would give us x plus y dy over dx equals 0. We can move the x to the other side. Y would be equal to dy over dx. Which would imply that dy over dx is simply negative x over y. The reason why we call it implicit differentiation is because the derivative implicitly depends on y also. Usually when we take the derivative, it's either a constant or 0 or just a function of x. But if the derivative depends on y, then it is implicitly dependent. Does that make sense? Which is why we call this implicit differentiation. Are we clear? And we should keep in mind that oftentimes we may not be able to separate the derivative nicely like I was able to do it here, in which case we will leave the answer as is. So we want to find the derivative of 2xy plus e raised y. Now, note that xy is a product of two functions, x multiplied by y. Y is a function of x, so you cannot treat y as a constant. So, since y is not a constant, and we would have a function x multiplied by a function y which is dependent on x, so we have to use product rule for the very first part. So the derivative of x times y, we have to use product rule. I'll call x as u and y as v. So we have u v. And if we use product rule, the derivative would simply be u v prime plus v u prime. U is simply x, v is just y, u prime is the derivative of x with respect to x, which is 1, easy enough. V prime, on the other hand, is not 0, again because y is a function of x. So what we will have here is dy over dx. We can take those and plug it in here. U is x, v prime is dy over dx, v is y, u prime is 1. So since we have now that we have the derivative of xy, we can plug it back in there. So that is simply for the first part. I'm going to erase this side. Now going back to the given equation, we found the derivative of x times y, which is simply x multiplied by dy over dx plus y plus the derivative of e raised y. Again, the derivative of e raised y is not 0 because y is a function of x. So I'm going to treat y as x, and I know if I did that, the derivative of e raised x is simply e raised x, but we have e raised y. The only additional step that we have to do is multiply by dy over dx. And set that equal to 0. If we combine the derivative terms, we should be able to solve for dy over dx. Distribute the 2, we have 2x multiplied by dy over dx plus 2y plus e raised y multiplied by dy over dx. Those two terms have dy over dx in common, so I can group those two. So move the 2y to the other side. So 2x dy over dx plus e raised y dy over dx would equal to negative 2y. dy over dx is common in both terms, so I can pull that out. If I pull that out, in the first term, I would leave behind 2x. In the second term, I would leave behind e raised y. And that would equal to negative 2y. We can't solve for dy over dx now. So would be negative 2y divided by, I'm dividing by the term on both sides, I would get 2x plus e raised y. So anytime you have an implicit equation, which is the equation that we have here, then the derivative oftentimes, for the most part, would depend on y itself implicitly, which is why we call this implicit differentiation. Does that make sense? I will let you try one. Can I erase this slide? Let's see, find the derivative of Okay, I'll give you about a few minutes for you to try. Let's see if you can use it right. Okay. That is just a function of x, so what is the derivative of 3x squared? What? 6x. Y is a function of x, so we can't just say the derivative is 0, but I can treat it as x for the time being. And what would the derivative of e raised to x be? It is simply 2 e raised to y. What are we missing? We are missing times dy over dx. Minus e raised negative 2y. Negative is going to come to the front, so or negative 2. E raised minus 2y. I am treating y as x. But since it is y and not x, I'm going to multiply it by dy over dx. Good? Now we can just combine terms and simplify. It is not always possible to isolate the derivative. Keep that in mind. If you're not able to isolate the derivative and say dy over dx is equal to something, you can just leave it as an equation. So I've chosen the problem in such a way that the derivatives can be solved because it's easier to understand. So I want to solve for dy over dx. So the first step is to move 6x to the other side. Negative times negative is positive 2. If 6x moves to the other side, it becomes negative 6x. What do we have in common between these two terms? We have a 2 in common. We have dy over dx in common. So if I pull those out, in the first term, 2 and dy over dx have been taken out, so we would have e raised to y. In the second term, 2 and dy over dx have been taken out, so we would have e raised negative 2y. And that would simply be equal to negative 6x. I'm trying to solve for dy over dx, so I have to divide by 2 first. Negative 6x over 2 would simply be negative 3x. Then I have to divide by that term on both sides. So dy over dx would simply be negative 3x over e raised to y plus e raised minus 2y. Does that make sense? So that's what we call implicit differentiation. Things could get really complicated with implicit differentiations, especially if you try to find the second derivative and so forth, but this is elementary calculus, so this is all you need to know. Are we clear? Yes? Okay.